అండ్ మీ ఫ్రెండ్ జాయిన్ అవుతున్నారా?
I ping him. It's okay. It's up to him. If he can't join, I mean, it's okay. Let's proceed. I mean, we'll not wait
ఓకే.
for
గుడ్.
him further.
హుహుహు.
If he joins, then I can. No worries. So, yeah. అండి ఇఫ్ యూ డోంట్ మైండ్ అంటే తెలుగులో చెప్తానండి లేకపోతే ఇంగ్లీష్ లో వెళ్ళిపోదామా
ఎనీథింగ్ ఈస్
అంటే
ఫైన్. సో
మీకు ఎలా ఫ్లెక్సిబుల్ అంటే నేను అంటే సరే ఇంగ్లీష్ కొంచెం బెస్ట్ అండి కొన్ని వర్డ్స్
మీకు ఏది
తెలుగులో
కంఫర్టబుల్‌గా గో విత్ దట్ అండి. సో, వి కెన్ గో
సరే
విత్ ద ఫ్లో.
ఓకే
దట్స్ ఇట్.
ఓకే ఫైన్ అండి సో దెన్ ఐ థింక్ ఇంగ్లీష్ ఇస్ ఫార్ బెటర్ ఓకే అండి సో టుడే ద టాపిక్ లైక్ వాట్ ఐఎమ్ గోయింగ్ టు కవర్ ద అజెండా మెయిన్ థింగ్ విల్ డిస్కస్ అబౌట్ ద స్పార్క్ ఆర్కిటెక్చర్ అండ్ దెన్ in Spark, we'll talk about transformations. I mean, what are the things, deals that we deal with in transformations? And basically, we'll deal with the actions. And first thing is Spark architecture, and then transformations, and then basically actions. And then I'll talk about data structures in Spark.
Yeah.
So once we talk about data structures in Spark, then I'll talk about Spark components. So what and all are the various components to be provided by Spark, and then what is the purpose of each component. And then once that is done, I'll talk about Spark cluster managers. So and in Spark, under Spark cluster managers, there are various types of cluster managers, and which one will be used more often in that industry level. And once that is done, then I'll talk about how memory is calculated as per the job level. So basically what I mean to tell over here is, so in Spark, whenever you submit any Spark submit application, so there will be a place where you will request number of cores, number of executors, number of nodes, and then minimum executor memory, driver memory, executor memory, and what exactly are all these actions, like how memory is calculated. This is one of the famous question, and even as part of interview level, even whenever we are dealing with, so you will be getting out of memory errors in Spark. So in order to deal with the out of memory error, this is one of the thing like we'll follow. And then and then I'll also give about memory level techniques in Spark. So basically memory level techniques basically will help you to overcome out of memory errors. One of the approach could be, we will be increasing the number executor memory, driver memory, number of cores, executor cores, and the other techniques could be to understanding implementing the memory levels in Spark. So memory levels in Spark. So once this is done, the next approach could be like to understand more about wide and narrow transformations. So these are the main things that I'll be covering it today. So basically now when you talk about Spark architecture, so the flow goes in this way. So first I'll talk about Spark components, and then I'll give an introduction about the data structures, and then I'll talk about transformations and actions, and then next Spark architecture, then transformations and actions, then I'll talk about cluster managers, and then how memory is calculated, and then we'll talk about this 7, and then wide and narrow transformations. These are the types of transformations. So then I'll talk about these things. So now I already said earlier, as per this, what exactly is Spark and what are the various Spark components. So Spark, as I said, is basically a framework which computes the data processing inside a memory and ensures that it is 100 times faster than MapReduce. Why is it faster? The entire computation will happen inside the memory, and it is also an open source platform. So basically you need not to pay anything to use Spark application. So you can use this as an open source and also distributed parallel processing engine. So what exactly is distributed parallel processing engine is, as we know, it stores the data in a distributed environment, so that whenever you want to store a data, since the data is stored in a distributed environment, you can store the data at a various node levels. So internally data will be stored at the levels called as nodes, which is nothing but data nodes. And what is the word parallel processing engine? Whenever you execute any Spark task, it internally splits the data and executes the data in a parallelized manner rather than a sequential manner. So because of that, the computation will be pretty much faster compared to any other frameworks that we used as per at the big data level. And coming to the Spark components now. So that's the meaning of what exactly is Spark and what exactly is Surface. And Spark mainly supports two types of batches. I can say that two types of processing engines. One is batch data processing. The second thing is streaming data processing. Majority of the time that we deal with this batch data processing. So what exactly is batch? Both will be supported by Spark framework. Using Spark, you can achieve both the tasks. So what is batch data processing? Batch data processing is something like where the data will be stored at a certain location. Either it can be HDFS, it can be S3 locations in AWS, or it can be Azure Data Lake Storage Gen 2 in Azure, or it can be MySQL database, or it can be any of the NoSQL databases. Data will be stored at a certain level, at a certain particular storage level. You'll read the data and then process the data, and finally performing various data cleansing activities and data pre-processing activities. Finally, we'll be loading the data back to the destination systems. Either it can be cloud systems, or it can be MySQL databases, or it can be NoSQL, or it can be various file formats that we discussed earlier, like Parquet file format, Avro file format, CSV file format, text file, ORC file format, depending upon the business requirement. And for dealing with streaming data, mainly we'll be using a tools or components called as Kafka. And when it comes to Azure, you'll have it in the form of a service called Azure Event Hub. And when it comes to Amazon Web Services, AWS, we have something called as AWS Kinesis. So these all will be used with Spark, so that you can make use of a Spark parallelized components, all the frameworks that we'll be using, like distributed engine. Spark is intolerant in fault tolerant manner, and it can be lazy evaluation. You can make use of all these things along with batch data and streaming data. So this is one of the pretty much thing. And now I'll talk about the Spark components. So Spark provides various components. So where in order to components is basically used along with Spark. What are the various tools and technologies we can use with on top of a Spark, and you can make use of it. So as I said earlier, we'll basically have something called a Spark core, and the second thing might be Spark streaming. So Spark core, I'll tell you what is the main meaning of that, and Spark streaming, and second thing will be Spark SQL and Mesh mlib. And we also have other things as Spark, PySpark, and then Spark Scala, and then Spark Java, Spark R. So these are the, and those comes under this, and you can write Spark, PySpark, Spark with Scala, and we can also write the other things. So in this way, we'll be having various Spark components. So now coming to the what exactly is Spark Core and what exactly is Spark Streaming. So Spark Core is something like whenever you are dealing with any particular things. So Spark Core is an entry point for our program. It's almost an equivalent to a Spark session variable that we will be creating. So for that Spark session variable, you'll be passing a configuration that you required to your particular job to run a particular job. The thing to particular a particular job. So you'll be creating a Spark session variable, and then you'll be passing all these particular various components to this particular one. So now next comes the Spark streaming. So what Spark streaming? Whenever you are dealing with, again you'll be creating a Spark session variable on top with the help of Spark configuration and Spark core variable, and then you can integrate it with Kafka. And so if you want to know, how Kafka works, basically it has a producer, and so that I can explain you later. And even you can write a Spark SQL queries, and even you can interact. You can even write with machine learning algorithms as well, and Python, Spark, and then Spark using Scala. These are the various things that one can perform on top of this using Spark framework. So in addition to that, when it comes to the clusters managers, so
One quick question, Rashika Garu.
yes,
So,
yes.
when you say batch data processing and streaming, for streaming live, for live data we use Kafka, but for batch processing we have different tools, right? So, can you give me a brief, like, okay, what could be the how to do those, batch processing, and if not after the Spark architecture, also you can If you can
Yes, I'll give
give.
right away. No worries. So, yeah, it's a good question. So, batch data is something about, as I said, like which will be stored at some place, and then we can make use of the data at a certain interval of time. In real time, when you are working with any real time data, there will be a
Mhm.
scenario like where you every 6 months there will be a refreshment period. After 6 months, new data will be loaded. So that 6 months. So imagine the data is stored in HDFS. So what I will do was, it's not about HDFS alone. You can use now when you're using cloud ADLS, Gen 2, S3 buckets, or NoSQL databases, or it can be SQL data tables, whatever we are storing, or it can be file formats. So data can be present anywhere. It's a batch data where the data will be stored, and then you retrieve the data, process the data in the form of a batches. So batches is something about, like, rather than extracting a data, live streaming data, you will be storing a data which is stored at a certain interval of time, stored at a certain location, extracts the data. So for this particular one, we'll write a scripts using Spark. So we'll make use of a Spark framework, and we'll be writing scripts in Python or Scala, or few
Mhm.
companies even use Java as well. And we'll be writing these things. And when it comes to the big data ecosystem tools, we can also use some tool called as Scoop, Flume. So what is the purpose of these two tools is, like, Scoop is basically an exporting and importing tool. So when we'll use Scoop is, so basically whenever you want to trigger any particular extracted data or load a data from MySQL databases to HDFS, so then we'll be using Scoop export command to load the data from MySQL, that is relational databases, to HDFS location, and HDFS location to relational databases. So we'll be using Scoop export command and Scoop import command. So this is one of the thing. So we are just like exporting a data from MySQL to HDFS, and vice versa, HDFS to MySQL. And here there might be a one interview question, like which famous question: how many reducers will run in the backend when you export the data? Okay, so basically what I'm asking is, when you are loading a data from MySQL to HDFS, internally it runs certain mappers, and then it will convert the data where the processing is happening into a reducing framework. So how many reducers will happen? So here the answer for this question using Scoop is zero reducers, because we are not performing any aggregate operations or any windowing functions. We are just mapping the data. So here, just mappers alone will be getting launched, none of the reducers. We don't even need a reducers over here. So we are just mapping the data from MySQL databases to HDFS location, so on HDFS to MySQL. So in this case the answer will be zero, because we are not, when reducing will take place only when you are applying or performing any of the aggregated functions, like minimum, maximum, or group by key, reduce by key, shuffle by key, sort by key, coalesce, repartition. When you apply these operations, only then the reducers will get launched. So this is one of the Scoop thing. So when you talk about Flume is basically a streaming data tool where you can load the data from one certain location to another location. Kafka is an extension of Flume. So where there are a lot many disadvantages using Flume, and then they came up in the next versions of Spark framework or whatever streaming tool. Then they developed a framework called as the data live streaming tool called as Kafka. So that is the one thing. And now for loading the batch data, for your question, so the one thing is, since it's a batch data, you can use Scoop to export the data. If the data is present in HDFS, or it can be ADLS, or it can be S3 location, you can load the data to MySQL tables. From MySQL tables to HDFS, you can use the Scoop command. Or the other approach could be, you can even write a data scripts using Spark Python or PySpark or Spark Scala, perform all the various transformations and actions, and then you will be writing the data into the HDFS locations. So this is the second approach. What is the third approach could be? You can even load the data by writing a Spark SQL queries. So where you can apply various group by, reduce by key, all the operations, not only group by, reduce by key, even you can apply various operations. So depending upon the requirement, and then you will be loading the data. So here the Spark's scripts will be written basically using Python and Spark, Python and Scala as part of a data engineer, because Java, many of them are not using, because Spark is pretty much scalable with Python and Scala. So this is the main reason. So how we will be writing. So in real time, when we get a chance to work with batch data, these are the main approaches that we will follow to load a data. So either, if see, apart from these three things, what else could be the data sources? So these are the main data sources. So you might have data sources only at these places only, nowhere else. Either the location can be HDFS, that is ADLS Gen 2, or it can be S3, or it can be NoSQL databases, or it can be SQL, or it can be file formats. So these are the various things that can have. So one can have data locations, data present at these locations. So we will not be worrying much about what data that we are using. So these are the various things that we need not to think much about this. So you got an idea about like how we'll be working with the batch data and the tools and the steps.
Yes, I do get that.
Yeah,
But one question here as well. So
yeah.
you said the batch data, like for this batch processing, we will like set up some time. So as I was started working on as system analyst, right? So in our company, they are doing that using Xena. So is that like once we write the Spark code, so we keep the script in the Xena? Like how does it work? Like that's what I wanted to know more. Not
Okay.
only like
See,
any scheduling tool, like not only that.
yes. See, once entire jobs are developed, right, we will be having a scheduling scripts mainly called as Woozy,
Oh, okay.
Rundeck, Rundeck, Airflow, and even you can have cron job schedulers. So these are the four schedulers available. Even there might be any other schedulers as well which can be worked in the pretty much the same way. So basically, what is the purpose of schedulers? So imagine we are working as a team. So I developed a job, so which I gave you like where the scenario was extracted data from one of the MySQL tables and load it into the HDFS, perform various transformations, and then I asked you to give me a aggregated result of saying that joining the data from multiple tables, applying window functions, various subquery results. And then I asked you to write some actions. And then finally I said, right now, you will be the first person like who will be testing the job. So
Mm-hmm.
what you will be doing is, so you will go and when you are running the manually, you can test your job. So once the job running manually is done, you any software systems like that we are developing a particular jobs has to be scheduled to avoid manual intervention. So that's where scheduling tools comes into the picture. So among all the tools, Uzi, Rundeck, Airflow, or cron job scheduler, you can use any of the scheduling tool. It mainly has two components, mainly coordinator.xml, coordinator.xml file, and workflow.xml. So basically, what are these two files is coordinator.xml and workflow.xml will one file will contains the sequence of actions. So basically, one contains the sequence of actions and the other contains the time to trigger the job in a 24-hour format. So if you want to trigger the job at a certain interval, like every day at 10 a.m. in the morning, you will be scheduling this job at 10 a.m. in the morning so that it will trigger the job automatically. And you can even configure the various options saying that email to. So once the job has been done, the status of a job, whether the job has been failed, completed, or it's ran with some logs folder, you can even configure the data so that an alert statement will be returned to this particular email, and then accordingly user gets alert, and then accordingly he'll be able to check the data. Now, what does this content coordinator.xml file? I said you certain actions. So what are those actions? So you see, as a person, if there are some jobs, right, there are dependent jobs. So basically, imagine I need to in order to start with my task, I need to get the data from I need to get the data present in tables. So this is my requirement. So only if the data is present, then I will read the data and then next proceeds the task. In a worst case, what if data is not there in the table? So because that might be the another job like who has developed by another person. So once that job has been done, next comes my job like where it will read the data from the above tables. So here you will be doing certain validation checks. So validation checks mainly contains all these operations, like where it is satisfying all the prerequisites of a data job to trigger this job or not. So in that case, you will be writing a scripts to check all the prerequisites for this particular thing. And then once we are done with the prerequisite checking, then the jobs will get triggered. And I'll tell the job, get the data from all these two tables. Once that is done, load the data into HDFS location. Once the data is loaded into the HDFS location, run the Python. For example, if I wrote a Python file, Python 3 file name.py. So this is how we'll be running a Python. Run the job, or if you want to, if it's a Spark job, the Spark submit parameter looks like this: Spark submit hyphen class name hyphen number of executors hyphen number of cores driver memory, so number of executors. So I'll tell, that's the concept today I'm going to explain, like how many executors we need to take, how many number of cores we need to take, driver
Okay.
memory, how much we need to consider. So these all the actions will be present inside the script that they develop, so that once the job started, it won't be dependent. So we have to ensure the prerequisites has to be satisfied in order to trigger this particular job. And then you can even configure an email as well, so wherein there is an option to email to, and then you can provide your n number of emails, and this can be done. So these things can be developed using four ways. One is UZ scripts you can write even rundex schedulers, even you can make use of an airflow as well, and even you can make use of a cron job scheduler. So this is how, using this particular schedulers, we will be able to schedule these jobs, and then jobs will trigger automatically. Remember, these all are sequential jobs, not for streaming jobs. So schedule, you can schedule the streaming jobs as well, but whenever if there is a dependence task on the other jobs, so in that case these all are called as a sequential jobs, because it is expecting the other job to finish his out to finish their output, then only my job will be input for the, as once the job has been done, that output will be the input to my job. So these kind of jobs will call it as a sequential jobs.
So one question here. So all
Hmm.
this data flow we write in the Spark any script file, and then
Yes,
in the coordinator and the workflow file we will mention, okay, at this particular time you need to trigger this. So once it is like completed, if it's the result, we have the result, then we will determine the next step in the coordinator file, right? Is that what my
yes, yes,
understand?
yes, yes,
Okay.
yes. So finally, once the job has been done, you might have told what needs to be happened in the job. I mean, when I said about what happened in the job,
Mm-hmm.
read the data from a HDFS file, and then depending upon the script that you develop, you might have wrote some transformations, like reducing group by key, salary. I mean, whatever the data that you want to perform, like join the data from multiple tables, and
Yeah.
final data, the output data. So imagine that next, once the data given by a data engineer to the data scientist team, it will be used by a data scientist team. So he have a data, and he'll use that particular data in the form of a CSV file or any file format, and will be further consuming. He'll be performing data modeling techniques, whatever he wants. So for that purpose, we will be writing the data into a certain HDFS location, or it can be any of the file formats, and then he'll consume the data. So whatever the transformations that you mentioned over here, it will be done that particular job. The entire operations will be done. Finally, you'll be writing a data at a certain location as per your requirement. So these are the steps only to trigger the job. So script scheduling is just to schedule that. It won't, it's like it will check for the prerequisites for the job, and only to schedule that. You can't add any transformations inside a scheduler.
Okay.
Okay, that
Gotcha.
entire transformations, if you want to add all the operations that you want to aggregated results, whatever, perform inside the job, run the job using schedulers and schedule it. So scheduling is mainly to schedule it. So we can't write your own transformations. So only the prerequisites you can check to what are the prerequisites that happens to my job to trigger. So that alone you can check it over there. That's it.
Okay, only the prerequisites for this in the scheduler, but apart from that, everything needs to be in
Yeah,
the script
everything
file.
will be in the script file only. So
Okay.
which script? Sorry, yeah.
Uh, And these script files, are we placing in the Linux server, or do we
Yeah.
have like, are we deploying into the GitHub, and like how do we call these scripts?
Yeah. So once this is done, these files, right? So next
Mm-hmm.
comes the deployment. So once the scheduling is done, so there are, I mean, since I work for with three companies, so as per my experience, so there were in one of the company that we all the three ways I work. So basically, one thing was directly we will store the data into a Git, and then once that is done, so from Git you'll be using a CI/CD pipeline called Jenkins.
Yeah. Okay.
So once you use the CI/CD pipeline called Jenkins, so here once the code has been committed into the Git, right, we'll be creating a develop branch and then merge it with that. Once this process is done under Jenkins, Jenkins is actually a CI/CD pipeline. So and you will be having various operations saying that build, test,
Test. Mm-hmm.
code coverage, run, code test, smell tests. These are the various things available. So you will just go to your particular they might have been already configured. So the
Mm-hmm.
environment name, whether it's a development environment or development or environment name, and
Mm-hmm.
the job name. So whatever the job that we develop, there has to be a unique name for that. There has to be a
Sorry.
unique name for the, yeah, yeah. Sorry, there has to be a unique name for each job. So you will have that particular, hello.
Yeah, yeah. Go ahead, Andy. I can hear
Okay,
you.
so there has, yeah, yeah, there has to be a job name. So once the job name has been done, you have to select the branch name. So from which branch? For example, most probably whenever you're deploying, so initially you'll be having your own branch, and then as part of a good requirement, good code standard process, so you'll be having a master branch. Next to the master branch, you'll be having a develop branch. So basically, every code has to deploy in development environments from develop branch. So once it is working successfully, all right, then you will be integrating it with the master branch, and master branch will be deployed to production branch, so that it will be easy whenever if something goes wrong, you can even
Oh,
revert back the codes as well. So now you'll be selecting a branch name, and then once you select a branch name, and there will be an option to give a build in Jenkins. So once you
yeah.
do that, so the build will be done with and then you can will be sharing this build ID, share the build ID. So now, once you give a build, automatically the job will be running, deployed. Deployed in the sense the job will run in that particular environment, and finally the job will be keep on internally that whatever the branch that we had developed, right? So it will be
Mm-hmm.
deployed. The job will be keep on running, and then you will be sharing the build ID so that the job will be keep on running in the particular clusters now. So
Oh,
deployment, yeah, this is one of the way that we had followed.
okay. I got it.
Okay,
Um.
so now the other approach, so the other deployment approach, what many people more often can use is, so using manual deployment as well. So manual deployment in the sense like people, what we will be doing is, so as part of a big data, more probably you will be developing a jar. So basically what is jar is like basically a combination of all the Python dot class files that we had developed, which is nothing but a jar over there.
Sorry.
So
Can you come
basically
again?
by, yeah, jar is basically, we'll call the definition as Java archive file.
Yeah. So these jar files are like all the Java program, the Java code, right?
No, it's not about not about only Java file. It's
Oh,
about
okay.
every, even in Scala also, or even in Python, dot class file. So every program that we write, right,
Mm-hmm.
internally, I mean, we are writing it in a high level language. High level language is nothing but our programming language. It
Yeah.
internally gets converted into machine language, which is in the form of zeros and ones. So this, if you see this bytecode, that generally the term that we use is a bytecode. So that particular thing we'll call it as a, in every code that you are converting, even though it is in your Python or language, it will be converted into zeros and one code. So that particular file will call it as a dot class file.
Yeah.
Okay, so these, now combination of all the dot class files, or how many ever files we are using, will make it as, we'll call it as a jar. So that's what I'm trying to convey. So now with the help of this jar, so basically what people can do was, so you will be developing a jar. What, how this jar will be developed, like using, you will be giving using build tool. So if you might have heard, build tools are mainly we have maven,
Oh, Maven,
sb,
yeah.
yeah, maven, sbt, gradle, gradle, Even you have various tools, but these are the three things which more often we will be using that. So using these build tools, you'll be able to build a jar, and then finally you'll be able to give this jar to the team, or as a developer, if you want to develop this particular job, or build a jar, copy it into the location in which environment that you want. So this is one of the way. So this is the first approach where I started my career, which I work. This is one of the thing, like, so nowadays, at that time still we have Jenkins, but we are not using more of end-to-end pipeline for Jenkins. So nowadays many of them, like even now, apart from Jenkins, you are having Kubernetes and Docker. So you can directly build in containers, and then you can easily deploy the job. So which makes the work pretty much faster. So this is how the deployment things works.
Okay.
Okay. So you got it. So still you have any particular queries over here?
Uh, yeah, I'm good with the batch processing. One more question. Sorry, because
Yeah. Yeah.
uh,
Please, please. Okay, no worries.
I was new to this one, so I have a lot of questions. So
Yeah.
on
Yeah.
the streaming data, right? So using Kafka, we take the streaming data, and
Yes.
how do we process that? If there is anything that can we process this any jobs or anything on the live data at all?
Yes. 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 100%.
We can.
One
Okay.
before answering to this question, brother, are you getting some information from here, or if you have any queries, you can interrupt me, brother.
Yeah, I'm sorry. I'm taking a lot of time.
No, I'm
Yeah,
trying
no
to get.
problem. Yeah, yeah, you
I'm
can
trying to
understand.
get
That's way better.
whatever I don't understand. I will let you know tomorrow. I will just listen it again
Okay,
and then I'll let you know.
cool, brother. No worries.
Yep,
See, for
I'm good,
your
Rashik,
question,
from my
right?
end too.
Oh, Amjad. Oh, super, man. Super. So if you have any query, you can just stop me in between. But whatever the questions that she is asking, right, even whatever the terms that I'm using, so these are the famous interview questions as well, bro. Now, whatever I'll ask, so I'll be speaking some terms. So if you have, even you can ping me after this when I'll connect with you separately as well. No worries. Okay. Now for this question, the question that she asked is, now she got some idea about like batch data, how batch data is stored, and how to process this particular data. What happens in the case of streaming data? So streaming data, we'll call it as like where the data will be loaded lively. The moment it loaded the data at a certain location, within fraction of seconds, data will be consumed by consumer. Now,
Um, Rashekar garu, sorry to
yeah,
interrupt, but one more question here. So when you're taking the live streaming data, so are we taking this data, I mean, as it is a live stream, so is there any particular, do we set up any particular period of time? Okay, at the, like for every 1 hour we take the data, or like that, or like it's like simultaneous cycle, like continuous cycle?
no, that's there in when you are using Kafka, there is a term called retention period. So retention
Oh,
period is mainly tells you that how frequently you want to get the data, and how
yeah.
many days that do I need to store the data in a producer window, in a producer. So you can have that data. So the moment one producer produces a message. So here, when you are dealing with Kafka, so there are some technical terms like what we need to aware of it. One is producer, and the another thing is consumer. Another thing is topics, zookeeper, partitions, offset, offsets, retention period. So now, basically, for your question, girl, so I'll just talk about these terms so that you will be aware of, like, whenever I use a topic or some name, you will be aware of that what exactly am I representing it, so that you can understand in a better way. So now, first thing I'll talk about producer. So producer is something about like from where are we getting a data from? So the source. So basically, in real time. So the one of the real time example that I can give right now was I work for a client called Marriott. So Marriott, like it's a revenue management system. So where I work for a client. So basically, what we have done is earlier their revenue system, their revenue management system, whatever the hotel in it's a hospitality one. It's a hotel industry. whatever the rooms that had been booked by multiple users. So before 1 week, imagine we book I mean we had booked a particular room like before 1 week, but I might cancel it one day before that room. So without using this Kafka streaming live data, what used to happen was, so at once, so since the room has been blocked, so the room has been blocked and I can cancel it at any time. So in that case, the moment if I cancel the data, so still it shows, because without using batch data, until and unless they refresh the data, the room still shows that it's blocked for me, even though I have canceled the data. So that's the reason they said like they are losing lot much of revenue from their perspective. That's where every hotel industry, they are migrating towards making use of a live streaming data, so that the moment if a person cancels a particular room or whatever the ticket it can be, the very next minute it will be available to the other users, so that who can book a particular ticket and they can get a maximum revenue. They might be charging some cancellation fees. So who will be producing a data in real time? In real time, no, I mean, we will be acting like a consumers only. As a developer, we'll be acting as a consumers, because producers are something like from the previous jobs, or someone will be producing the data from a certain the intervals of time. So you will be accessing the data. So what, how we will ensure that we'll be accessing a data? So there are, imagine there are hundreds of producers. So who can produce the data? And 100 consumers. And if he's, there is something called as like, this is a repository like where he'll be producing a message or whatever the data. So now this data, like every producer will be having for a particular name as a unique identification. He'll name this particular message that I'm sending in the form of a particular name that we'll call it as a topic. So basically, topic is a name. It's like myself, it's like unique identification to identify from which producer this has been coming. So it's like for the first producer, he'll be having a name called as topic called as revenue management, and the other person can have a topic name as hotel management. The other person can name as like airline and airline domain. So in this way, topic is something where a producer can have an understanding, so that it can have a unique name, so that consumer can easily access that particular topic that you want. So what if I don't have any topic name here? So 100 producers will produce the message at this particular location. So which message I want to consume? A consumer, he needs to know, I need to consume a message coming from first producer name is hotel management system. So then I'll be writing a script to consume that particular data in the form of a topic names. Then I'll be able to get the data. So this is the purpose of that name topic. So now we're talking about like producers, consumers, topics. So next comes what was the So next comes the zookeeper and then partitions. So
Translator,
basically, yeah,
bro. Yeah, in this, I mean, consumer means who consumes the data. Is that what you mean?
yes.
Like the
Consumers means
developers.
yeah, a developer. So as a developer, see now, as once you start working on it, initially you will be a consumer. You will get a data from a previous producers who will be producing it to a certain topics. You will access to the topic, get the data, and our requirement will be, finally once again you will be using Spark streaming framework along with various transformations and actions. You will be converting the data, and finally they will tell you that once your processing is done, entire pre-processing is done, write the data into another topic name as hotel management system. So now you are writing the data into you are a consumer, you are reading a message from him. In this case, you are consumer, and finally you are writing the data into this particular topic. This topic will be consumed by some other person. So for him, you are a producer. For you,
Okay.
some other previous person who produced a message is a producer. So in this way, these jobs will be happening, but there won't, it's not like I will be storing the data over here in this topic. There is no storage here. This is the difference. So earlier jobs store the data for 6 months, how much ever time you want. The moment you push a message to this topic, automatically the other person will consume the data. There is the delay in just a fraction of seconds. That's it. So that's where
Okay.
we'll call this as a streaming data, and these are the various topics. And I mean, if you look at the architecture, right, the how it works, and basically, so that will be pretty much makes sense, bro. So
Okay.
these are the things, and yeah, that's the thing. So that's correct one. And next comes the word called zookeeper. So mainly, Zookeeper is something like works as a coordinated service between each producer, each consumer. So internally, when you produce each producer, when he produces a message, right, in the topic, internally the messages are stored in the form of a partitions. Internally each message, so basically you'll be having the data, so in the format, so internally the messages will be stored in the form of a partitions, so that the data will be equally distributed, and if you want to consume the data, it's like a distributed Spark framework only. So in this way we will be storing the data and the processing will happen. So majority of the time we will be getting the data for streaming in the form of an JSON format or XML format. So this is the other names could be like semi-structured data. So because mainly whenever we are dealing with semi-structured data, we'll be using as a destination majority of the time as NoSQL databases, which are mainly MongoDB and Couchbase. So these are the two things. So any doubts still now? I mean, if you again have, you can just let me know.
No, I'm good.
I'm good
Okay.
as well.
Pretty good, thank
Okay.
you.
How about Amjad? Is it fine now?
I'm good, yeah.
Okay. Thank you, brother. So now, uh, okay. So now I'll just explain you about the Spark architecture part. So basically, how Spark works, I mean, whenever we submit any job, right? So how it works basically. So basically, Spark, as we know, it's a framework. It's a distributed framework which mainly works in a distributed parallelized engine, and it has both. It supports both parallel processing, sorry, both batch as well as streaming data. And this is one of the thing. So now every Spark program, so it starts with something called as driver program. So now, what I just let me draw the diagram, then I'll explain you. I'm just I rotated my, it's making it as a horizontal so that it will be easy for us to visualize that. I mean, I can't fit that thing over there. We'll be having exhibitors. Okay. So basically, whenever we submit, have you ever heard of a term called Spark Submit command? So have you, I mean, whenever we are working with, right, so basically for running any Spark job, it has to run using Spark Submit command. So if it is a Spark job, so how the Spark Submit command looks like was, as I said, Spark Submit hyphen hyphen class, and then you'll be a class name, and then hyphen number of cores, and then hyphen number of executors, hyphen driver memory, hyphen minimum executors, hyphen maximum executors. So every Spark Submit program has to run with the help of that format. So internally, this will be present somewhere in the scheduler. So if you might have seen over there, so if you might have got a chance to develop a scheduler from scratch, then you'll be having a this, or if you're running a jobs through command line arguments like bash scripting shell, so then you'll get a chance, you have to run this job through manually. So once the job has been scheduled, so I don't think you'll be getting a chance to see a Spark Submit command because the jobs will be automatically running. So you need not to think much about that particular one. So now, so whenever from when you submit any Spark Submit command, so basically this is how it looks like. So Spark Submit and then hyphen hyphen the class name of the package name, and then hyphen hyphen number of executors, hyphen hyphen number of cores, hyphen hyphen driver memory, hyphen hyphen executor memory. So in the same way, you'll be having various parameters. So the moment this is how we'll run. So in the end, you will be having hyphen hyphen jar and the file name dot jar. So this is how this command will be mentioned in this particular one. So when you run this particular one, so driver program, the moment you run this internally, so automatically driver program will be getting launched. So once the driver program is getting launched in this program, so this command we are actually calling this jar file, as I said earlier. So what is this jar file? It is actually a combination of all the dot class files. So inside each dot class file, we know every program has a main method, so that the execution will begin from main program. So driver program will get launched, and then driver program will internally call this particular main method present inside the class name. So now the execution has went into the main method. How it went? With the help of driver program. Now, depending upon the number of resources that we mentioned, like number of executors 5, number of cores 10, driver memory 18 GB, executor memory 20 GB. So depending upon the number of resources that we mentioned over here, it will ask cluster manager saying that for my particular job submitted by a user, I need these many resources. Cluster manager has all the resources. Cluster manager is the place where you will be having entire cluster configuration. So it is the root. So where it will be having entire cluster configuration, total memory available by a particular cluster, it will be present over here. So once driver program will request for this particular one, so it will, depending upon the resources that you request, it will check whether I have sufficient resources or not to give an access to you, so that your job will be running. So it will check for the cluster manager launches. So then if the if it has enough resources, then cluster manager will launch executors. What is the executors? So basically, what are the number of executors? So here I mentioned number of executors as 5. So it will check whether 5 executors are free or not. Now, as for the namesake, I just wrote as 4. Internally, it will be hundreds of executors. So that all depends on how big the cluster configuration of each configuration is. You can have 15 executors, 20 executors. So it will check whether whatever you have been requested over here is available or not in a cluster manager. Is it free or not? If it is free, then I will allocate you to this particular one. So now, if it is imagine cluster manager has the resources free, and it will send you the request saying that your job, you are having enough resources. Then driver program will say, okay, I'm good to go. Then it processes the logic that you had written in your spark submit command. So what does it contain in your spark submit command? As I said, it basically contains all the operations. We'll call it as transformations or actions. So every operation, either it can be join, group by key, count, sum, distinct, everything we will be calling in Spark. It has to be either transformation or action. So don't think about the name whenever someone says what are Spark transformations. So Spark transformations are basically a transformations which is mainly creates an external transformation data by mapping from a given data. So transformations is every transformations in Spark will basically creates you a new transformation all the time. So why? So this is the main difference. So only once you triggered an action, once action triggers, that means when I said about once action triggers on a particular data frame, until and unless if you call an action, entire execution won't begin. So it will wait for you to call a particular action. So this is the reason why we'll call it a Spark as lazy evaluation. Okay, so this is the thing. So now, yeah, let me go back over here. So so that's how the cluster manager, what is the purpose of cluster manager? And that is the purpose of cluster manager only here. So cluster manager will only help you to launch the resources, and the actual work will happen across each of the executors. So an executor, and internally every executors converts, this is nothing but wn is nothing but worker node. So every worker node will have executors, and we'll be having one wn node 1, node 2, node 3, node 4, and internally every executor converts the data into tasks. So it splits the data across each task, and then finally the work will be the executors mainly processes the task, and the result will be sent back to the driver program again. So accordingly, the entire execution will happen. So now, once this entire execution will happen, so this is how the entire cluster configurations. This is how the internally how the Spark execution framework will happen. So Spark clusters managers. So when I talk about cluster managers over here, we have three kind of clusters managers. So I'll just talk about, one is Yarn cluster manager, another one is Apache Mesos, another one is standalone. So these three are main. See, Yarn mainly stands as, Y stands for it, YET, A stands for another, R stands for it, another resource, R stands for resource, N stands for negotiator. So basically, whatever we are using over here as part of a clusters framework, so we'll be using Yarn as a resource manager, and Apache Mesos is also one of the cluster manager which will be used depending upon the clusters. You can use it, and standalone is basically used when you want to test your code in local with one executor alone. It won't have many executors. So that's why when you are developing a code in your local, like, see, these clusters are too huge in terms of an amount. So basically, every programmer or everyone will have, so only the companies can invest money on top of these clusters, not a persons like us. So now, any queries you have across any of the terms over here, whatever I wrote over here?
One question. Sorry, it might sound silly. But
Yeah, yeah,
what is the edge node?
yeah.
How
So
does edge node
basically,
capture?
yeah, here edge node is basically the place, we'll call it as an edge node or name node. So if you might have heard a term called name node, so here internally once the data will be stored, right? So here at this point of time, whatever we are having, we talked about Spark session variable. So when you clusters manages whatever the worker executor wherever we are storing the data, this is as part of Spark framework. So every Spark that we are having, so internally this entire thing will run on top of HDFS data. So in HDFS, when you are storing the data in HDFS, see now Spark is a framework which mainly used to run your piece of code. Coming to the storage part, that's what I said. So mainly Hadoop has two components. One is HDFS, another one is framework. So now I talked about Spark architecture, and coming to the edge node that you talking about, it will be present over here. How the data will be stored in HDFS? You will be having a name node or edge node, and you'll be having multiple data nodes. So now, do you think whenever I said about Spark framework, Spark runs on top of HDFS data. So internally, how data is stored, then it will be stored in the form of an edge name node. The data will be present across edge nodes. Not sorry, name node, edge node, both are same. Data nodes or slave nodes, we'll call it as. So there are other things called as there are various daemons that we'll call name node, data node, secondary name node. If you might have heard a term called job tracker, task tracker. These are the terms that we had in Hadoop version 1. In Hadoop version 2, we still have name node, data node, because HDFS is still there. They haven't replaced HDFS. These two will only be these are the terms which are used by MapReduce as a framework. These are the two terms which is used as part of a processing framework. These we can mean, rather than our job tracker and task tracker, we can make cluster manager and resource manager, task manager. So these are the things. Your doubt is clear. When it comes to storage only, we'll talk about edge node or name node or data nodes. Hello.
Yeah,
Yeah.
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 Sorry.
Okay. So this is the main thing. So yeah. Hmm. I mean, the term that I talked about, lazy evaluation. So okay, I'll tell you about. But before that, I'll talk about some examples of wide transformations and narrow transformations. Okay. So basically, whenever we are dealing with any transformations, right? So basically, what exactly is transformation? Amjad, are you following, Amjad?
Yeah, I'm getting few things. Yeah,
Yeah, yeah. So
thanks for that. Thanks for
imagine, guys. Yeah, yeah. So every spark that we are writing, every piece of code that we write, everything that we write in Spark, it has to be either transformation or it can be action. So the usual terms that we know even in SQL. So what exactly is transformation? So transformation, basically it's a function that produces new data structure from the existing transformation. Okay. Now, what exactly is this? So if I gave there are two types of transformations. One is wide transformation. Another thing is narrow transformation. Okay. These two are pretty good, important. Just by heart the names. I'll tell you what exactly is wide. So basically, wide means a broader. So basically, there are certain transformations. So where you will be having the data, like where the data will be present across multiple partitions. So as we know, Spark stores the data in a distributed framework. These are the internally data will be stored across partitions. So if the data is present across multiple partitions, so basically, if I talk about for example, A comma one, A comma two, sorry. Okay, imagine these are the partitions. What is partition? Partition is a place where, like, every spark that we are storing the data, internally it will be storing the data across a partitions inside the storage that we are storing the data. So now, since the data, if you see in real time, the data might be stored across hundreds of partitions, so the data will be pretty huge. So now I just take an example. So where the data I want to count is how many times A has been repeated. Once A, 2, 3, 4, 5, 5. So I need to get output as A5, and then how many times B? B1, 1, B comma 1. How many times C? 1, 2, 3, 4. How many times D? 1, 2. How many times E? I mean F1, Z1. So if I said, like, this is the output I need from your, I need from as an output. So in this case, the data is present across multiple partitions. So this is one partition, this is partition, this is partitions, this is various partitions. So in this case, when you try to extract a data, right? So it will actually get a data from multiple partitions. So in that case, this partition will take pretty much, so you have to search for the entire partition among here, among here, among here, among here. So in this case, if the data is very huge, guys, the data that we deal with, big data is like petabytes and even in terabytes as well. So in this case, it will take ample amount of time to extract the data. So because of that, if the data is very huge, you might get out of memory error. So this is one of the things. So in that scenarios, you will be using where you'll apply a certain transformation which extracts the data stored across multiple partitions. We'll call that particular transformation which is causing more shuffling of data, called as wide transformation. Got the definition, guys?
Actually, I had doubt.
Yeah.
I mean, see, you are saying we are transferring. So if we are transferring A1 data into another transformation, so
Hmm.
the transformation data will be stored as A1 or A2.
No, the transfer. I just want to know the count. How many times A has been repeated? For example, A1, A1.
Yeah.
So, like, it's my requirement that will be stored in a new transformation that I want to store the data. It will be stored across a new partition data, right? So it's my requirement. So I need this as an output.
Yeah, got it.
Okay. So this is the thing. Amjad, have you got the definition of wide transformation? So this is the definition of wide transformation in real time everywhere. But in real time, the data will be pretty huge. I'll give you the transformations. What and all comes under wide transformations? What and all comes under narrow transformations? So now, Amjad, got it, brother? Don't get me
Yeah.
wrong. I'm just
No, no, no,
asking
no.
you so that.
No, I totally understand. So white transformations, yes. This is the same in SQL indexing cluster indexing. Um,
Yes, yes.
yeah,
So basically
in the sub
indexing, yeah, yeah. Yes, yes.
that's
So
the
which
same formation.
basically extracts the, yeah, yeah. So but there won't be a concept of shuffling of data. And here there is a lot much of shuffling of data. So which basically called as white transformation,
Mission
where
and narrow.
it's simple. Data will be present across multiple partitions, so that when you extract or when you perform a group result across multiple partitions, which basically takes more time, so that that data which is causing more time to happen, that particular transformation we'll call it as wide transformation. So some examples of wide transformations includes reduce by key, group by key, join, intersection, distinct, sort by key. And these two are very important, brother. Repartition, coalesce. So these are the transformations wide that we'll call as a wide transformations. And coming to the narrow transformation, got it. I don't know what's. I mean, sorry. So got it, sister. You got your this. You got this particular query. I mean, whatever I said here about the wide transformations. What exactly is transformations and that?
Yeah, yeah, I got it. But I haven't, looked into it yet. So if I have any questions, I might ask you, like maybe.
Yeah, yeah, yeah.
And
Sure, sure. Even in tomorrow's class, you can just ask me. And
thank
now I'll talk about what exactly is narrow transformation. Guys, if you are, I mean, facing any issue in understanding, just let me know. I can re-repeat as well how many number of times. That's not at all an issue for myself. Then it's an opposite of wide transformation. Then the data will be present across in a single partition, where you'll be having a data in one partition, so that you'll extract the data. So which basically won't include shuffling of data, and it won't take long time to process the data. Now the examples: map, flat map, filter, sampling, union. So these are the examples that we'll use. So they won't, I think majority of them, they won't ask about narrow transformation. So they'll just stretch you more on wide transformations. Can you give some examples? So the moment when you talk about group by key, reduce by key, sort by key, join, partition, repartition, coalesce, the very next question they might ask is, what is the difference between repartition and coalesce? This is one of the famous interview question even nowadays. I mean, everyone will ask about this. So I mean, just I already explained earlier to you guys, I guess, but just from my side, just make this as an what can I say, for tomorrow, just try to explore on this particular part. Tomorrow I can explain you this particular one, so that this is, even you, when you give an interview, you might expect this question as well. So this is the one thing, but I can explain you tomorrow if you want. I can explain this particular one, what exactly is this, even I can tell you. That's not an issue from my side. So now, then we'll talk about the actions. So what exactly are actions? So now we'll be having certain things called count, take, head. So which basically returns a certain value. We'll call it as an action. Got it? What is the difference between transformations and actions? So now I used a term called lazy evaluation. So every Spark program, Spark itself is lazily evaluated. The reason why we'll call it as a lazily evaluated. So which main thing, there are two things for this particular one that we are calling it as a lazy evaluation, because if I wrote a program, so you might have seen, well, RDD equal to some transformation. So this is the program that we'll write. And then if I use df dot join of df2 on equal to id. So if I wrote this particular program, guys, I mean, this is not the, okay. So now I'm creating a new df. So basically now if I use df dot count, so this is a transformation. This is action, guys. This is a white transformation. And here I used the format of reading a CSV option. This is also a transformation. So every transformation, I'm creating a new RDD, new data frame or new data structure. That's what I wrote. I wrote a definition as transformation as well. So if you see in my here, function which produces a new data structure from the existing transformation. So every transformation that you apply, it creates a new data structure. A data structure is nothing but either RDD, either data frame, or data set. Spark, we can have only three data structures. Either it has to be data RDD, it has to be data frame, or it has to be data set. So this is the thing. Sorry. Okay. Okay. So now, this is the thing. So now, when the reason when we said about Spark is lazy evaluated, so internally, guys, so whatever the Spark transformation, if I, for example, every Spark transformation that we apply, yeah. So every transformations that we apply will stored in the form of an graph. What is the name of a graph? I'll tell you. So if I apply a transformation, so this is a map. For example, I applied a map and then flat map and then group by key, and then once after group by key you have used join, and then you have used repartition, and then in the end you have used count. So these all are transformations. What is this transformation? This is narrow transformation, this is narrow transformation, these three are wide transformation, this is an action. So internally, all the transformations that we apply, internally it will be creating a graph in the form of, that graph will call it as a lineage graph. That term that we'll use as lineage. So it's lineage graph or lineage graph, people will say. This lineage graph will call it as, only the execution will only happen only until unless if you didn't call action, these transformations won't get executed and return you the result. If you want to see a result from the transformations that you wrote, you have to apply an action. So that is the reason why Spark, we are calling it as a lazy evaluated, guys. Got it?
Can you
Can you
repeat it?
repeat it?
I didn't get it exactly.
Okay. Okay. I'll just, yeah, repeat it. I mean, for all the three guys, no worries. So
Mhm.
every Spark, I mean, so for example, let me write a piece of code. If you want, if you are able to understand this, what I'm writing, if not, just ask me, I'll explain each line by line as well. So this is basically whenever we write any Spark program. So this is one of the skeleton how it looks like. So what I'm trying to read in the first step is I'm trying to create an RDD file by loading a file from a HDFS location. This is clear, guys. First line. Imagine it's a CSV file. Okay.
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 Yeah.
Yeah. Okay.
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 So, okay. So
Okay.
now
So
once
now,
that is created, I am applying a transformation that is filter to filter the data. In that there is a column called ID. I'm just filtering only the ID is equal to 123. So I'm just filtering only for those records. ID is equal to 123. I only want those records whosever ID is 1 to 123. It's not about that. I just took an example. So in real time, you can apply various transformations, guys. Now, once that is done, I'm creating a new data frame by joining with this with the first data frame. This is RDD, and here I created RDD1. So I'm joining these two based on the name column, and whichever is common names in the RDD1 and RDD and RDD1, extract the data, and finally I'm applying a group by key and then reducing the data, and finally I have used a transformation, and finally I am writing the data into a certain location,
Into
this is a
CSV
save
file.
command, yeah, into CSV
A-
file. Yes.
Again into CSV file. Okay.
Yes. Again, yeah, it's not about mandatory like every time I use CSV file. There are various file formats: CSV file, Parquet file format, Avro file format, ORC file format, text file format. It all depends on your requirement. Whichever file format we can use that file format. So now, internally, this how internally this is executed. Execution might have happened is this is this all code will whatever I wrote over here will be preparing a jar over here and will be used to run in the form of a Spark submit command. So now there will be a main method for this particular program. Main method will be getting launched at the first, then it comes over here internally. All these things that I have used, what are the here, what are the transformations that I have used? Filter is one of the transformation, map is one of the narrow transformation, join is
Right.
wide transformation, group by key, reduce by key, and then right is a action, guys. Repartition is one of the transformation. So in the end, in order to execute this your particular Spark program, in your program you have to call Spark action. If you didn't call any if you didn't call any Spark action, your Spark program won't return you the value at all. This internally will be getting stored in the form of a lineage graph. That's the main thing.
Mhm.
Okay. And how this particular lineage graph looks like is the previous one that I wrote. What is that? Yeah, this is the one. So here I just used map. So in this, the same way you have used another transformations, map, flat map, group by key, reduce by key, join, repartition. So there are various things. So I mean, I'll just share you some couple of links, because even I usually refer directly the Spark website, like Spark API frameworks only, directly to refer more on that. So you can just I'll just share you that particular links and even other best where you can easily understand this particular thing. So this is the reason why we'll call it a Spark lazy evaluated. So now whatever I think I had covered, whatever we had covered, like mainly have any doubts on Spark architecture, what is wide transformation, narrow transformation, lazily evaluated, some examples of wide and narrow, and batch processing, streaming data processing. So this is everything is clear, guys, or if you have any query, you can ask me.
For now, I'm good, Rashikar Garu.
How about Amjad?
Yeah, this is coordinating with my SQL SQL processing.
Yeah, yeah,
So
yeah,
it's the
yeah, yeah.
same,
Even
but just only the
even
terminology like
see,
narrow
yeah,
transformations
see,
and wide
as
transformations.
a data engineer, if you are good at SQL, Spark framework is nothing as far as I feel. You
Okay.
just need to know. That's the reason I told like everyone who ever asked me for any suggestion, I'll say, yeah, if you want to become a data engineer, you need to be good at five things. One is framework, which is nothing but Spark. Another thing is a query language, SQL. Another thing is any language, programming, Scala, Python, whatever the language. Fourth thing is NoSQL database. Fifth
Mhm.
thing is cloud. Sixth thing is any of the scheduling tool. This is for batch data. Remember, this is for batch. For streaming, you need to know Kafka. Kafka is main thing, and you need to know how to integrate Kafka with Spark. Then you are done. So these are the main skill sets of a data engineer. And machine learning, that's a different story, guys. I mean, you need to, don't talk about. If you want machine learning, then I can explain in a very good manner, because even that's my pretty much core area. Of course, data engineering both. So these are the things. So now, guys, whatever the next now I'm going to talk about, it will be a pretty much more often mathematics. So you might when you might have given an interview, right, or when you might have got a chance to work in real time. So you might have heard a term called clusters, right? Every cluster has certain memory configuration. So now imagine I am running. I imagine. Okay, this is the program that I wrote. There, imagine there is some 100, this CSV file that I'm loading the data, it has 10 GB of data. Okay, so 10 GB of data that we are loading it into a CSV file. How much memory I need to say that from the cluster per configuration, I need to get those many number of resources, that is number of cores, number of parallel executors, number of worker nodes. I need that many particular tasks, right? So how to get that particular one? So how you will be wondering. So I'll write a Spark submit command over here now. So have you ever, I mean, you might have faced seen this. Okay. So now the question is how to come up with right number for each of the parameter. Okay. So in the same way, you have, let me show you one example. You able to see my screen?
Yes, we do.
Yes.
We do.
Yeah.
Yeah. So if you see this command, right? Okay. So we had mentioned, yeah, we had mentioned about this is the spark. Forget about this is the location that you want. So this is like if you want to go over there, like where which location. So using command line arguments, you use cd space directory, changing their directory, and then it starts from here. Spark hyphen submit slash is basically used since these all a semi. I mean line by line separated. Uses slash in terms of a programming, but in command. When you're using bash scripting, we'll specify it using slash over there and hyphen hyphen master. So basically, master is nothing but where you are actually running a job. So master URL is basically where your name node, the cluster name nodes is. Basically, master is nothing but in our case, yarn. So AN is the cluster resource manager that we'll call about. So here we'll mention it as an yarn and deploy mode. So there are three kinds of deployment modes. Cluster mode, I said. I mean, cluster mode is the main node. Cluster mode is nothing but and resource manager where you want and standalone mode. So this are, and there is another mode as well where local mode, sorry, local mode, cluster mode, standalone mode, and configuration. So if you want to pass the configuration values, we use this particular thing. And if you see here, driver memory, you will pass certain value. Executor memory, executor course, jar, class name. And if you want additional arguments, you can provide these arguments as well. So yeah, see here, I just mentioned over here. Yeah. So whatever we have discussed, see, local Kubernetes engine, these are the various modes, and this is how things. So now if you see here, yeah, now if you see here, they just kept randomly driver memory 8 GB, executor memory 16 GB, executor course 2, and this is the thing. Now what I am going to tell is how they had come up with 8 for your program. How they, this is very important interview question, and I mean even interviews basically ask this question, how to come up with the right number of executors, because in Spark we will face more oftenly out of memory error. So how we will overcome out of memory error is, this is one of the way how we can overcome out of memory error will be using identifying correct number of executors. So there are three approaches. I mean, the first thing was, so the first approach what people generally will follow is, yeah, we'll call it as minimalistic approach. Okay. So what exactly is minimalistic approach or whatever we are trying to convey is, so basically it means, even though as we know Spark is a distributed framework, correct? So distributed framework, so we have to ensure that we will be running the data in a distributed framework so that the execution processing time will be pretty much smaller and the computation will be pretty much faster. So it doesn't mean you can't use all the resources available in your cluster, because there has to be other jobs which has to be used by the in running in the same cluster. So for that particular one, you also need to give aside some particular configuration. So how much ever memory is required, you have to configure only that much particular memory. Now, for finding the correct parameter values, you need to have four rules. I mean, basically, we need to, whenever you find about that particular configuration value, when you are configuring that, you have to keep four values in mind. Basically, as I said earlier, there will be some demands running in the background. I mean, is it okay if you can extend? I mean, like, I'll take till 10:30. Is that okay for you guys, or is it overburdened today? Because it's all about calculations part. If you guys are okay, then I'll continue. If not, I'll continue. How about this explanation? There are three more. It might take until 10:45. If it's okay for you guys, I can extend it. So, or else we can start tomorrow. So you might feel overburdened, and then. So how is it, guys?
For me, I want to go with tomorrow.
Okay. So how
Me
about
too. I
you,
have office
brother?
tomorrow.
Okay. So then you, you mean let's continue tomorrow? Is that you're saying, brother? Sorry, everyone.
Yeah.
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 Okay. Okay. Fine then. But I'll tell you this. Okay. This tomorrow will start freshly because this is very important. But whatever if you had any queries in that, right? So even if you are facing any technical issues in understanding a particular term, you can just bring back to my notice tomorrow. In the first couple of minutes, we'll discuss whatever the queries that you guys are having, and then accordingly we can discuss about that. And one more thing, if you guys are, I mean, facing any issue with respect to your work, or I mean, if you are working right anyway, so in a data engineering perspective, so even you can, we can discuss, that's not totally an issue. But I might not be able to code, but I can definitely assist you, like how to proceed, how to overcome this issue or that issue.
Cool.
Okay,
Yeah,
okay.
sure.
And if you
Can
if
you
you
send
want
me
to
the
learn,
link? Can you send me the link which you have opened just now, the browser, that how we distribute the load, that
yeah,
we
yeah,
can,
I think this
just if you
was
can.
I can,
Yeah, this one. Yeah.
yeah, I can share
Just-
you right away. Do we have chat option over here? I don't see.
We do
Okay, I
have it.
Yeah,
see.
we do.
Yeah, yeah, I see. Yeah, I just pinged it over there. So yeah, it's okay then. I mean, if you guys have any questions, you can ask me, guys. If not, I think we'll drop off, and tomorrow we'll connect at the same timing. And one more thing, guys, from 23rd, right? So I mean, I mean, my next sem starts from 23rd from this month. So Friday alone, I mean, in that case, I mean, I usually have a classes in the evening itself, like usually from 5:45 to 8:25. So if it is okay for everyone, then we can connect sometime in the early, or if not, we'll connect after my class, like somewhere 9:30 timing, so that I'll be back by 9:30. We can connect at 9:30 accordingly, if that is okay from 23rd.
Okay.
Okay,
It's
then
just
we can
Friday,
discuss.
right?
That's not. No, every time. I mean, no, every day. I mean, from
So
my
it's Monday to
college
Friday.
basically. Yeah. My college. No, my college is only, and I have 2 days alone. So I mean, it's basically 2 days only. So that's not
Or
only
what are
Monday.
the days?
I'm not sure the days, but Monday,
Okay,
Tuesday, and Friday. Among these 2 days,
okay, okay. That's fine. Friday,
Monday,
Friday we.
Tuesday, and Friday.
Uh, Fri- Friday,
Uh,
if something happens, we can work on Saturday or Sunday.
Yeah.
yeah.
If you can have
Sometime.
Saturday, that will be very good, because even I can extend for 1 more hour, and I can explain in a very
Yeah,
good way. I mean,
we can
we can
catch
extend it.
some. We can catch up
Yeah.
some hours. Depends upon. It's
Yeah.
all
Yeah.
up to other
Okay, brother.
other team members too. That,
Yeah.
If it's
Okay, brother.
Tuesday,
That's not
I
an issue.
don't think I would be able to join in the morning sessions because I will be back
Uh-huh.
from office like 6 or sometime around. So
Okay, cool. I mean, it's okay then, no worries. So, or else sometime early morning, if it is okay for you guys, or else we'll see. But before 23rd, I think I'll be free. So, even if you want to change the timings, and if everyone is okay, so even guys, I mean, what I'll do now after this call is we'll create a small, I mean, a WhatsApp group among us. So, if you have any queries, you can just paste over there. I'll be able to help you with the queries, definitely.
Yeah, sure.
for sure.
Okay,
Thanks.
fine, bros. Then, okay, then let's drop off if there is no queries.
Yeah, sure.
Thanks. Thanks, guys.
Yeah.
Thanks for your
Okay,
time.
thank you.
brother. Thank you. Thanks
Thank
a
you.
lot. You can stop the recording, brother.
Yeah.
Yeah.
Just disconnect the call. It's fine.